Hello everybody and welcome back to the next installment of Learn Math with Python. Today we're going to discuss the subject of powers and roots. Firstly, we'll delve into the subject from a mathematical perspective, where we'll talk about powers, sometimes referred to as exponents. These will include square numbers and cube numbers. Then we'll turn our attention to roots and explore the differences between square and cube roots. Finally, we'll switch over to Python and see how we can work with powers and roots, exploring the implementation with pure Python along with various other modules to simplify the process. Let's get started. Right, let's start off with powers, or in a scientific context, they're commonly referred to as exponents. Essentially, powers are shorthand notation for indicating repeated multiplication of a number by itself. They consist of a base number raised to a power which denotes how many times the base is multiplied by itself. Let's take square numbers for example. A square number is the result of multiplying a number by itself. An example being 10 raised to the power of 2, or 10 squared, is equivalent to 10 times 10, or 100. Now let's look at cube numbers. A cube number is raised to the power of 3, which means it's multiplied by itself 3 times. For example, 5 raised to the power of 3 is written as 5 raised to the power of 3, or 5 cubed is equivalent to 5 times 5 times 5, or 125. Powers can also be any integer. An example of this can be 2 raised to the power of 4 is the same as 2 times 2 times 2 times 2, which equals 16. Okay, let's talk about roots now. Think of them as the opposite of powers. Instead of multiplying a number by itself, roots help us find what number was multiplied to get a certain result. For instance, if we square 2, we get the answer 4. So the square root of 4 tells us what number when multiplied by itself is equal to 4. That number is 2, because 2 times 2 equals 4. However, square roots have 2 solutions, because multiplying a negative number by itself results in a positive. Hence, in this case, the answer is also minus 2. Similarly, if we take the square root of 25, it's plus or minus 5, because 5 times 5 and minus 5 times minus 5 equals 25. Okay, let's discuss cube roots. Cube roots are represented with the root symbol, but with the number 3 placed just before it. Just like square roots, cube roots are the inverse of cube numbers. For instance, the cube root of 125 is equal to 5. Alright, we've covered enough theory. Let's switch to Python and discover how we can use code to compute powers and roots with ease. Alright, let's fire up your favorite IDE or code editor. I'm personally using Jupyter Notebook. First off, I'll import the display and math functions from the IPython module. This enables me to render LaTeX, which is commonly used for scientific and mathematical notation. I'll delve deeper into LaTeX in another video. To display 2 squared, I'll type display open bracket math, open bracket, single quote, caret 2, single quote and 2 closing brackets. We can enlarge this by adding \huge to the LaTeX. Alternatively, you can use \large. We've learned from the slides that 2 squared is simply 2 times 2. Let's replicate that in Python. If you watch my previous video exploring arithmetic, you'll recall that we use the asterisk for multiplication. After executing the cell, you'll notice that Python renders the value as 4. However, that's multiplication. We want to compute 2 squared in Python. To raise a base number to a power, we use the double asterisk operator. Let's assign 2 double asterisk 2 to the variable x. Upon running that cell, the output is printed. As anticipated, it's 4, which is mathematically correct. Okay, let's make this presentation more aesthetically pleasing by embedding it into LaTeX. To do this, we'll use the math function and pass in an f string, allowing us to embed the variable x. This gives us a proper mathematical statement. Okay, let's try 10 squared. We'll follow the same steps as before, but this time we'll assign 10 double asterisk 2 to the variable x. As you can see, it prints out the correct answer of 100. Alright, let's move on to cube numbers. It's essentially the same as before, but this time we'll use a power of 3. Let's try 2 cubed. First, let's print out some LaTeX to see how we mathematically write 2 cubed. I'll use the display and math functions and write the following. When we render the cell, you'll see the correct notation. We've learned from the slides that 2 cubed is simply 2 times 2 times 2. Let's replicate that in Python with simple multiplication. As you can see, that's equal to 8. Now, let's try using powers. I'm going to assign 2 *3 to the variable x. Upon executing the code, you'll see it also prints out the correct answer of 8. Once again, let's make this look neat by embedding it into LaTeX. I'll type the following and execute it to give us the correct mathematical statement. Alright, let's shift our focus to roots. I'll use an example from the slides, the square root of 4. Similar to how we handled power examples, let's print out some LaTeX to see how we mathematically write the square root of 4. However, mathematically, we can also express this another way. Writing 4 raised to the power of 1/2 is equivalent to expressing the square root of 4. I mention this because it'll aid in understanding how we write it in Python. Let's also print this out using LaTeX so we can visually see this in mathematical notation. Okay, in pure Python we use the latter approach, expressing it as the base raised to the power of 1/2. I'll create a variable x and assign it the value of 4 raised to the power of 1/2, wrapping the 1/2 in brackets. Upon executing that cell, the output is displayed. However, the output is 2.0, which is a floating point number. If you're unfamiliar with floats, I recommend watching my video titled Understanding Number Types. In Python, when you perform division, even if it's dividing integers, the result will be a float if the division isn't perfectly even. In the expression for ** 1/2, the division 1/2 results in 0.5, which is a float. When you raise a number to a float power, the result will be a float. Hence, why it evaluates to 2.0, a float. That being said, let's make this presentation more aesthetically pleasing by embedding it into LaTeX. However, there are simpler ways to calculate the square root in Python, and one method is by using modules. The first module we'll explore is the math module. Let's create a new cell and import the math module. Then we'll create a variable x and assign it the output of the math sqrt function, passing in the number 4 as the argument. Upon printing out the value of x, you'll notice it also returns the value of 2.0, which is a floating point type. Well, what if we prefer an integer output instead of a floating point type? Luckily, there's another module called Sympy that returns an integer. Let's import Sympy and create another variable x, assigning it the output of Sympy's sqrt function. Upon executing this code, you'll notice the output is 2. Let's wrap up this section on square roots with another aesthetically pleasing statement by embedding it into LaTeX. Okay, let's delve into cube roots. First, let's print out some LaTeX to see how we mathematically express the cube root of 8. I'll utilize the display and math functions, writing the following. Upon rendering the cell, you'll observe the correct notation. Similar to the square root, we can also express this in another format. You might have guessed it, but we can write this by raising the base to the power of 1/3. In our example, it will be 8 raised to the power of 1/3. Let's generate some LaTeX to visualize this. In Python, similar to how we handle square roots, we can create a variable called x and assign it the value of 8, **, 1 divided by 3 within brackets. This operation calculates the cube root of 8 by raising it to the power of 1/3. Upon execution, you'll notice that the output is 2.0, which is again represented as a float. Let's explore the math module. The math module includes a function called cbrt, which was introduced in version 3.11 of Python. Let's assign x the output of math cbrt, passing in the value of 8. Upon execution, you'll observe that the value of x is also 2.0. Now, let's see if Sympy can provide an integer result, similar to what it did with the square root. Sympy also offers a function called cbrt, short for cube root. We'll assign x the output of Sympy's cbrt function with the argument 8. Let's embed the value of x into some LaTeX to neatly wrap this up and print the output. As expected, it's an integer value too, which appears more mathematically precise. And that's how you work with powers and roots in Python. There are various methods, and these were just a few examples. Feel free to experiment with the code to familiarize yourself with the different approaches. Did you find this video helpful? If so, I'd greatly appreciate it if you could give it a thumbs up and consider subscribing to my channel. I'm committed to bringing you more valuable content just like this in the future.